Okay, all right, we're back. So I'm going to pull up Blackboard here, and I'm just going to get confirmation from Luke and Jonah that they indeed do, in fact, see my screen.
Yeah, I see it.
Awesome, awesome. This is good. So it's a little bit different look because I'm using the technology in the room, and this is good. This is good. I think I got a handle on what we're going to be doing. So let's take a peek at our calendar right now. As you know, this weekend I kind of populated that calendar for the remaining time that we have, which is truly about 2 weeks left, or a little bit over a week. So I'm going to scooch into October here. So we're right here on the 29th. We're looking at Learning Plan 6 today, and then we're going to move into Learning Plan 7. Those two learning plans are basically setting us up for creating engineering or complete detail drawing. So Learning Plan 6, which is going to be Chapter 7, is all about dimensioning, but essentially it's creating what we call a format and then also a template. And those are going to be the borders that we're going to be using for Learning Plan 7, which is going to be Chapter 6, where we actually start creating those drawings. So Learning Plan 6, Chapter 7 is going to be on dimensioning and that other stuff. So that's what I wanted to just kind of talk about with you today and hit some highlights here. But as you know, dimensioning is one of those things that it's always good to review. So we can't get enough practice dimensioning because it's something that is essential to your job, but it's also one of the things that it does take a lot of repetition to get really good at. So I am going to pull over my book, and we are going to look at some of the items here in Chapter 7 that I want you to pay particular close attention to. And I'm going to zoom in underneath here, and what I've got up here is the Chapter 7 dimensioning the dimensioning chapter. So this is, again, Learning Plan 6. I know it can be confusing, but it's Chapter 7 dimensioning in our Creo book. And this talks about, first and foremost, it really gives us a nice overview of some of the rules, the do's and the don'ts. And it also explains how in some cases, you know, it's kind of I like the approach that they take, because they're like, okay, these are guidelines, but you kind of got to step back a lot of times and be like, okay, how does it look and how does it apply to this particular drawing? So we've got rules, but we also have you know, just like anything else, exceptions to those rules. So I'm gonna kind of start here, and I'm gonna point out some of the illustrations that we see. So as we look at properly dimensioning a part, which is figure 7.1 here at the bottom of page 198, you'll notice a couple things. And these couple things are things that you have learned along the way with Connie, because most of you have had actually all of you have had her kind of for those base AutoCAD classes where you were taught how to lay out all of the dimensioning. Now this is going to cross over, even though Creo and SolidWorks kind of do some of that automatic work for us, but we've got to ultimately make sure that everything is to the standard in the end. So things like, we're going to try to put our dimensions between the views as much as possible, as much as it makes sense. Sometimes we want to pull some things away because of maybe room. So you'll notice that they have the 1-inch dimension here, okay? And so you might pull those away. Some maybe overalls are going to be to the outside, but we want to try to keep feature stuff to the middle here so that everything is you know, close to where it's actually dimensioned and where we see it as its true size. Whenever we have holes, we are going to dimension them where we see them in their circle view, okay? But if we have cylinders that are solid, circular features that are solid, so cylinders, those we're going to be dimensioning where we see them as the solid, or their what we call rectangular view, okay? We also need to remember that we have to keep in mind those symbols that you learned. So if it's a countersink, a counterbore, or a depth symbol, we see that come up here. Let's see, what else do we have? You'll notice as well, one of the things that I know Connie was very adamant about is that dimension lines cannot cross extension lines. So a dimension line is going to be the one that is going to be with the actual dimension itself, and the extension lines are the ones that are going to pull away from each one of the features. So you'll notice here that, so this would be an extension line, dimension line, and notice in these views that they aren't crossing over one another. So if, for instance, we would have another dimension here, we can't have an extension line crossing over a dimension line. That would be illegal. So they were really good about that. There is a criticism or two that I may have on their drawing, and it's actually in this dimension right here. One of the rules in the ANSI standard does say that we do need to have 2 arrowheads for each one of our dimensions. And sometimes people will do this, and I understand that it can be pretty readable, but this dimension 0.44 should be moved up or down so it would have its second arrowhead. Same thing with the reference dimension over here. This should be moved up or down so it has its second arrowhead. But like I said, sometimes people will overlap these to, I don't know, I guess I understand it's understandable, but it's not to the standard. So that would be a criticism I have of theirs. The other one that I have is that this arrowhead is crossing over an extension line. So extension lines should not cross over leader lines, and part of the leader line is that arrowhead. So this really should go maybe to the opposite side or move somewhere along that radius differently than where that dimension is. So that would be another criticism I would have on this particular drawing, okay? Is it terrible? No. but are those things that do violate some of the rules? Yeah. so just to kind of keep that in mind. But I also think it's important to kind of, again, step back and look at it and be like, are things spaced evenly? You want this to look good and to be nice and readable. We want to put dimensions, for instance, these 2 counterbores here, right? If we are dimensioning those in this top view, we should also, for its size, we should also be dimensioning their location in that same view, and we see that come across, okay? We don't want to dimension in one view and then have to look somewhere else for its location, okay? So that's something that you want to keep in mind. Keep trying to keep the locational and those size dimensions as close together as possible so that it's not like you're hunting for those elements, okay? So yeah, so that's that example. Now, here they do give you some dimension spacing, okay? So you'll notice here that we don't want to have the dimensions right up against the actual drawing itself. Even if it seems like it would fit, you want to have some distance away from it so that you give precedence to the actual view as well as the parts themselves. And then we want optimal or ample room between the dimensions as well. We don't want these super close together, and we don't want to stagger them too much because otherwise they just get too clustered and it doesn't look good, okay? So again, stepping back and seeing how things look. When we put center lines in place, anything that is in line with one another should get a center line so that you can see that relationship. So that when we're dimensioning on one side over here, we can see, oh, all 3 of these features are in line, and that dimension, the 1.12, applies to all 3 features, okay? So make sure that you're adding those. Also, when you dimension to a circular feature that has a center mark or a center line, make sure, and I'm gonna zoom in here because you can see it if we get in there real close. There is a gap. You want to actually start your dimension at the bottom of the center line. Don't go to the center of the hole. If you do that, then your gap is going to be overlapped with that center line. We want to see the gap between the bottom of the center line and the start of that dimension. Okay, so make sure that you have that gap there, and then also making sure that your arrowhead is not overlapping with any extension lines, which it's not here. Okay. All right. Oops, I'm going to go opposite direction here. Down here, looking at those leader lines, the leader lines we want to be reasonable in terms of their angle. The standard says anywhere between 30 and 60 degrees is a good optimal angle. We don't want to go straight on with our leader lines, and we don't want to go vertical. And we don't want to go too shallow. When we have them too shallow, they look kind of funny. They don't look quite right. So try to get this angle right here to be between 30 and 60 degrees optimally. Off that a little bit, but not much more. We don't want it to be too shallow or too steep. The other thing is we have to have a landing. We have to have a landing on a leader line, and we have to have an arrowhead. So we don't do things like this and then start, drawing. You have to have the actual leader, the landing on there. That's really important. That's part of the standard, okay? When we look down here and we're dimensioning radii, making sure that we put, however many that might apply there. But again, notice the angle that's at is between about 30 and 60 degrees. It's not too shallow, not too steep, and we have a landing associated with it. So that's the important thing there that we want to keep in mind. When we're dimensioning radiuses, that means that we're dimensioning a circular feature that is not a full circle or 360 degrees around, and that's why we put the radius on there, okay? If it is a full circle like a hole, then we put the diameter symbol in front, okay? Turning the page talks about fractional and decimal dimensions. Pretty much the standard now is no fractions anymore. You may see them on older drawings, but those should be converted over to decimal. So anywhere from 2 to 3 decimal places is appropriate. And they talk a little bit about that in here. I'm not going to read and focus on that too much. Now, but we do want to keep in mind that especially when we're looking at English dimensions, we want to keep our nominal sizes to acceptable fractional sizes, okay? So for just kind of talking sake, 3/16, that means if it's a 2-place decimal, we're going to call that out as 0.19. If it's a 3-place decimal, it's 0.188. And if it's a 4-place decimal, 0.1875, okay? Now, depending on the 2 or the 3-place decimal, we are then going to default our tolerance to our title block. So remember, even if you want to be like more accurate or you want to show the full number of decimal places for a fraction, you have to keep in mind that a tolerance has to be associated with that. And if you are going to be defaulting to the title block, then you do have to round to either 2 or 3 decimal places. If you aren't defaulting to the title block, then what you can do is you can either add your tolerance to that or put limits on it. Okay, and we know how to do that as well. So keeping in mind, especially when we're in the English world, we want to keep to our nominals should be on those fractional numbers, but we're not going to use the fraction as our dimension. Okay, and I know they did that a couple times in this book, which I'm a little bit like not really happy with, but because it's really not the standard anymore. It's decimals that we want to be using. Okay, and then a little bit more of that conversion stuff on the next slide here. All right. So standard size is preferred. So when we're in the metric system, to the nearest millimeter is going to be your nominal size. So much easier, right? So much easier. Let's look at a couple other examples here. Dimensioning angles. So depending on the type of angle that you have or what you're really interested in your feature, there's 2 different ways here that we can do it. You can dimension the actual angle, and here too I have a criticism on them because they're dimensioning on the part, which we know is like not a good thing and actually against the standard. So in this case, you would probably pull out an extension line here, and we would then, we would then have this go down, and we would, do our 45 degrees, this way somehow, okay? So they are really violating here. So I want to make sure that I'm pointing these things out to you so that you don't think those are acceptable, okay? But we would basically have an extension line, and you would actually pull it out and be over here, okay, with that 45 degrees. The other thing you can do is you can actually dimension the start and the stop of that angle for their location from either one of the sides, okay? That's another way to get at it without putting the actual angle on here. Now here we do have crossing extension lines, and that's okay. We just can't cross dimension lines with extension lines, okay? So dimension lines are here. These are the ones that extend from the actual dimension itself. Extension lines are these guys. So this is okay. That's okay. Dimensioning arcs, they give some examples there. And then also making sure that when we have fillets and rounds, so those are the ones that, we might say all fillets and rounds are a radius of 1/4 inch unless otherwise specified. So if there are any fillets or rounds, then if they're not dimensioned, they default to that note, okay? So that's a very typical thing to do because otherwise these little radiuses here would kind of, there would be too many dimensions. So when we can do that, we want to make sure that we do that. Adding finish marks, I'm not going to focus there too much, but just know that if there are special finishes besides what maybe are obvious on a drawing, we want to add those in. And those are going to be kind of those check mark with the number above them that are going to depict how smooth or rough the surface would be. And we'll get a little bit more of that work as we put more assemblies together. Here again, dimensioning, pulling those locations off of the part, being on the actual part is not acceptable. It just, obviously you can see this looks so much better, and we can see the perimeter of the actual part. Here it starts to get hard to really know what's what. So illegal, I'm going to call it illegal, not poor dimensioning, it's illegal. It's not to the standard, okay? So we're not going to do that. Much better, legal on the left. Dimensioning on a section view. Here too, again, I'm going to call it legal and illegal. So right here, best when we're in a section view, you're going to pull those dimensions away. Actually, not acceptable. You cannot dimension on a part. End of story. And you're not going to do it with the sections going through here. So these two, bad. Not going to do. This one is best. I'm not going to say it's best. It's the way to do it. It's the right way. Okay. Correct dimensioning over here as well on a contour dimension. So you'll notice here that correct placement is in order here. And what you'll notice the difference is notice how they are dimensioning to the top of the arc in this view. The rule of thumb here is going to be, and it really dictates, we are going to dimension where we see that feature as its true shape and size, okay? So even though you're going to say, oh, well, that's still the top of the part, okay, but by putting it in this view over here as a radius of 1.5 rather than the dimension from the center to the top of the part, we get an idea that that's a rounded feature, as opposed to over here when we just look at this L, we really wouldn't know, okay? We really wouldn't know. Same thing with the diameter. When I have a hole that I'm creating, I want to show that dimension as a diameter in the view where I see it as a circle when it's a hole. So over here as a side view, first of all, not acceptable for two reasons. It's not to the standard as far as dimensioning holes, but also notice in this view, you're dimensioning to hidden lines, which we also know is something that we don't do, okay? So multiple reasons here why you wouldn't want to do that, all right? Now, we also look at this view up here, and we'll notice that the cutout in the foot, if you would, for that L piece, so right here, this cutout, you want to dimension as much as you can, again, where you see that cutout, where it's cut out. If I go down to this view over here, and I just show the lines, well, now I got to figure out, okay, where are those located, right? And I'm looking up and down in views when I could just be dimensioning up here. So I want you to think about, as you're dimensioning, really, where is the best place? And I'm going to be scrutinizing you on that and questioning you on that when you start laying down dimensions. Okay? In our I'm going to say learning plan number 7, the last learning plan. Before we're done here, I know we're going to kind of get used to this again. And you've had Connie for dimensioning all the way up to this point. Okay? I do possibly work a little bit differently than Connie does, okay? And that's okay, two different instructors. But I do create, and I start at that basis of what does the standard say, okay? And I know the standard. So just know that I am going to be looking more to where you are putting items. And I know Connie emphasized this as well, and she's not here anymore. But like I said, I might not be exactly Connie, but the spirit is going to be the same, I promise. So as you can see here, look at things in terms of where is it going to be easiest seen, where I see the size and shape of that part, as well as part of why we have you take manufacturing processes in your first semester is for you not to become a machinist, but for you to start thinking in terms of when this part is made, where are they going to be looking for those dimensions? Where is it going to make sense to put the dimensions from that person's perspective that's going to be making this feature? And when they're creating that feature, they're going to want to see where the cutout is, where are those dimensions? When they're making the radius on the top, show me where the radius is, put that dimension there. Don't put it in the side over here that they have to start looking for it. okay? And you might be like, well, it's there. Well, yeah, but it's not in a good spot, okay? So take that manufacturing process, that person that's going to manufacture it into account and what they may be looking for or where they're going to be looking, okay? Now let's look at dimensioning solid cylinders, okay? Again, lots of illegal stuff going on here, right? Because of the fact that it's on the part. Those would be pulled off on either side, okay? But we do dimension cylinders in their rectangular view. So up on the top of page 208 here, you will notice that they have this rectangular view of this cylinder. The outside diameter of it is dimensioned in that rectangular view. The hole going through is going to be in its circular view, and any of the other holes as well. Okay, so see that here. This is good stuff. Over here. Here again, noticing that as we look around, wherever we see things as their closest true size and pulling those dimensions away from the part. Another thing I want you to notice is that the dimensions are a lighter line width than what the actual object lines are for the part themselves, and that's intentional. We can't be putting everything, if you would, all on the same layer or on the same line width, because otherwise you're going to start wondering, like, which is the part and which is the dimension. Okay, so notice that here. Dimensioning cylinders in their rectangular view, as we see, that looks good. Adding some symbols for counterbores, countersinks, callouts for drills and taps. Okay, now something that we don't do anymore, and they're doing it here, and I don't know if I'm opposed to it or not, and I think it comes from when you learned how to do this, but we no longer dictate tools or manufacturing processes on drawings. Okay, so in the case of this threaded hole here, you would not add the drill size, okay? Because if I'm making a 1/2-13 UNC, I'm going to actually get rid of tap as well, the standard drill size is what they're identifying there. So it's really redundant, and we're going to rely on the professionals who are going to be making this to know what the drill size is going to be. So that can actually be off of there. And your call out would just be 1/13 UNC-2B, and just 2B means it's the fit, and B is going to be how close that tolerance is. That's all right? And then through, this just tells us that it's going all the way through. We want to get rid of the tap as well, because tap tells us manufacturing-wise what to do. Okay, so we don't need that on there. So that can actually come off, okay? But when we look at the counterbore down here, notice that we have a diameter of 1/2 inch, and it's going to be 1.5 inches deep. That's a blind hole. And then there's a counterbore of 3/4 inch at the top there that's going to go 0.25 deep. And now what that eliminates is dimensioning in the side view, where we would have to create if we were going to dimension in the side view what these depths were, you'd have to create a section view, because you couldn't dimension over there where we have the hidden lines. Okay, so we can accomplish all of that description in one note, making sure that we use our symbols as appropriate here for counterbore depth, and then if it would be a countersink, we would use that as well. All right. Notice here that you can cross extension lines with leader lines. Okay, so that's okay to do that. Look over here, dimensioning slots. Typically, if that slot is going to be created on center, we're gonna dimension the centers, okay, from center to center, because you're gonna go in there with whatever the size of that radius is. Looks like it's a 1 inch diameter. Diameter would not be used here. It's 1 inch wide, so it would be a 1/2 inch radius, and it would be plunging down in and then going over. Okay, so these look good. We can also do it where you can go to the outsides of the actual rounds themselves, whichever dimension is more important if you're not really sure what's going to be used to manufacture that. Okay. Just kind of taking a peek here. Okay. Holes that are equally spaced. So I'm gonna go over here. This is on page 215. Let's look at holes equally spaced. So I will tell you, you may see at times, instead of written out equally spaced, you may see ES, just the two letters ES. That is an abbreviation for equally spaced. And then you'll notice that BC in back of the 5-inch diameter here, that means bolt circle. And sometimes you may see this all on one line in one note. So 4 by a diameter of a 1/2 inch, you would see ES on a diameter of 5-inch BC bolt circle, okay? But here they have them dimensioned separately, and that's totally fine. That's not a problem at all. And equally spaced here, because there's 4 of them, that means that there is going to be 90 degrees between each one of those holes on that bolt circle. All right, and then a couple other options here. I'm not seeing anything out of the ordinary. So on page 219, okay, they have like a checklist for dimensioning, and please take time to kind of look through this. This is a nice review. Now there are quite a few rules here, but there's, I think, let me see, there's almost 50. There's 47 rules, but they're great for remembering some of the things that I know Connie emphasized with you guys, and some of her things are on this list. So so take time to look that over, so that you kind of are prepared and kind of bring to mind again, because it's been a while since we've dimensioned. Okay. So once you've gone through that review of dimensioning, what I've done is part of there's two homework problems that you have to do. Okay, and one of the first homework problems are what you're going to do. Hold on, let me get to the end of the chapter here. One of the homework problems is you're going to answer these review questions. I have these on Blackboard, so you don't have to write out the answers manually. What you're going to do is you're going to go to the Learning Plan 6, I think it's called Review Questions, and you're going to click on that, and you're going to enter your answers directly into Blackboard, and I'll check them. But it's these right here. All right. So so those you should be able to find somewhere in the chapter. So make sure that you review the dimensioning, you do those review questions, and then what you're going to do is you're going to make a format sheet, and you're going to make a template sheet. Okay. Now a format sheet is where you're going to be creating your drawing border. Okay. So it walks you through the process of creating a standard drawing border. This way you're not drawing the border each and every time it comes up, right? And you guys have had the experience in both AutoCAD and SolidWorks where there are standard drawing borders, LTC drawing borders. So you're going to be making those in here for yourself and going through that process, okay? So step by step, I did this and it works perfectly the way that they say it does. So you're making the border, and I'm going to let you get creative on what you want to put inside. You can put mechanical, design, technology, Lakeshore Technical College, Cleveland, Wisconsin, whatever you want to put in here, kind of using their way as a guide. And then you can just, change around the font or make it bold or italicize it or whatever you want to do to kind of make it your own. Okay, so be a little creative there. Then you're going to be adding unless otherwise specified, what the tolerances would be. Now for us, I will tell you that for us, our tolerances for 2 place decimals are plus or minus 10 thousandths or 0.01. You want to do 2 decimal places here. And for 3 place decimals, it's plus or minus 5 thousandths. That's our standard title block, okay? So don't use what they're using here. So replace those with these 2 values, okay? Then you just follow along and create that.
What was the 3 place one?
Oh, sorry, plus or minus 5 thousandths for the 3 place decimal. Okay, I'll actually add that as a note to the assessment so that you see it there. Okay, and then when you're done, you're going to have your format sheet here. That's going to be your title block. Okay, now once you have that set, the format sheet remains the same. Okay, we can't really change anything about that after it's set. So once it's set, what you're going to do then is you are going to use it as the base for a template. Okay, so the template is something then what we can go in and now we can start kind of creating that when I open my drawing border, now I'm going to have a bunch of other stuff set up as well. Kind of like when you do it in AutoCAD, for instance, and you can set up all your layers and stuff like that, and that automatically comes in. That's what a template here is going to give you that opportunity to do, and then you can change it as time goes by. So they walk you through creating a template file then, using that format sheet as kind of the background. Okay, so so go through and create yourself an A-size template. Using that border, and then it's also going to put in place your top, front, and right side views is going to be one option. Then it runs through that, and then also filling in the title block automatically. Then you're going to notice you're going to do a 2-view one, and then you're going to add one that's going to be a 3D projection. Okay, and so those are the 3 templates then that you're going to be creating by the time you're done here. So when you submit homework for this, I'm going to minimize this guy. So if we go to learning plan number 6, which is the dimensioning, your homework file here, you're going to go down to the tutorials. So the 2 tutorials that you're going to, I'm sorry, the template, the format sheet, and the template. The template technically has those 3 templates in it. So you're going to take you're going to take 4 screenshots of your assignment here. Does that make sense to everybody? But it's technically 2 tutorials because within the template tutorial, you're doing 3 templates the whole way. Okay, so I hope that makes sense. You're just gonna, and I have the pages here for you to run through. And then this is where those review questions are for, so if you go in here, you're going to click on that. You're just going to begin this assignment, this assessment, and each one of these is 2 points, and it says, what is the difference between a drawing template and a drawing format? Okay, and you're just going to write your answer there, and you're going to continue to answer these questions, and then they get into like dimensioning, okay, for instance. So I'll do a submit and save, and it's going to say, you didn't put any answers in. I'm like, I know. So that's your homework for Learning Plan 6. So take your time and go through the dimensioning, and then create your format sheet, your templates, because then in the next chapter, chapter 8, which is the engineering drawings, then you're going to be actually, using those templates and format sheets that you created and putting dimensions on. So I want to make sure that we're fresh with that. Okay. Now I do realize that first attempt at creating those drawings probably is going to be a little rusty, okay? But as we get into then the next working drawings class, we're going to be like, making sure we get everything, figured out and perfected, okay, by the time we're done. So again, drawings and creating and putting dimensions on, the biggest, most important part of that job. I mean, creating the model is great. It really is. I mean, actually, you have an important job the whole way, but now when we create the documentation to communicate how to make that part and what the requirements are, that's essential. I mean, that's a big deal. So that's going to be our focus in the next half of working on Creo. All right, so this is kind of laying that groundwork. Any questions? Okay, so I'm going to let you work. It's kind of pointless for me to do run through a tutorial that has like 50 some steps to it when you have everything in the book here, but I wanted to make sure that you understood kind of what was in the chapter. So I'm just going to stop sharing briefly. Actually, before I stop sharing, let's look at the calendar. So Learning Plan 6 tutorials are due next week, Monday, by the end of the day. Today, your Learning Plan 5 drawings are due. So Learning Plan 5 is Chapter 6, right, Josh? Yeah. Chapter 6. So make sure that you get those Chapter 6 drawings done, and those are the patterns, right? Those are the patterns. And those are going to be due this evening by 11:59. And then Learning Plan 6 tutorials are due next week, Monday. And then the questions are due, I have them like due a week from today. Okay, so it gives you a little bit of time to go through those. And then we'll be moving on to Learning Plan 7 next. I'm probably going to be looking at Learning Plan 7 early next week, probably Monday. Okay, any questions? All right, okay, so good. A little bit different look here than from my laptop. And one of the big advantages is that our microphone is in the center of the room. So hopefully you can hear what's going on. So Jonah and Luke, were you able to hear Josh when he was talking? I'm assuming so. Hopefully a lot more clearer. Oh yeah, message from Luke. Yes, he said we can. And then that way it feels more like you're hearing what's going on rather than that muffled sound in the background and wondering what did they say. So so that's a clear advantage of using the room itself. Okay, that's all that I have for today. And let me know if you have any questions, and I'll get this for you to review. Have a great day.